Okay, so this is the lesson for um, graphing linear inequalities. And we're going to do 5 examples, I believe. And as I was saying, all of our inequalities model an equation in slope-intercept form. So if we can graph an equation in slope-intercept form, we can graph an inequality in slope-intercept form. 90% of it is the same. It's just a few things at the end that we have to look out for. Now, remembering when we had just regular odd inequalities, yes. I have an idea of how the graph is going to go. Is it just pointing that way since you're going further up? We'll get to that portion of it. We're going to start testing points to begin with, but yeah. Let's just start with the inequality symbol itself. Remembering when we had just plain old equations, one variable equations, and we were graphing them on a number line. When we had a less than or a greater than, it told us something about the point. What did it tell us about the point? Was it open or closed? Open points, remember? Well, here, what that's going to mean is it's going to be some people call it a dashed line or a dotted line. So what that means is the line that we graph itself is not going to be, it's going to be the boundary, but it's not going to be part of the answer. All of the answers are going to be ordered pairs in a region, okay? So this is going to be a dotted line, we're going to say. Kind of like that, dash dotted. We used to just make little dots. When we have less than or equal to or greater than or equal to, when we were solving inequalities in one variable, what kind of point did that give us? Closed. Here, that's going to be what's called a solid line, like we're used to graphing. And that's going to mean the line itself is part of the solution. Okay? So same as before, open point meant that number was not part of the solution. Here, dashed or dotted line means it's not, that line is not part of the solution. Any point on the line is not part of the solution. Things on either side will be, but not the line itself. When it's a solid line, just like when we had inequalities in one variable, that meant that that number was part of the solution. Here, any point on the line is part of the solution. So if you remember that, it'll be actually pretty easy. So let's start. We're going to graph this line. Where do we start on the number line if we're just graphing it like any other line in slope-intercept form? Where on the y-axis do I start? -1. Okay? And then use the slope. 6 over 5. You go up 6. So I would go up 6 to 5. And then across 5. Now, if you notice the line itself, it's either going to be dashed or, oh, see, I messed it up. So they're asking us to change the line. Do I want a dashed line or a solid line? It's got the equal to part. I want the solid point. Now, the other thing we need to do is we are going to shade either side of this. Now, I want you to get comfortable with testing points out to check for that. Okay? So we have to pick a point. The easiest point to pick, if it's available, is the origin, 0, 0. So this is called testing this point. Okay, so we're going to test this point out, 0, 0. Okay? So what we're going to do is we're going to go to our inequality and replace 0, 0 for x and y. So here we go. 0 is greater than or equal to 6/5 times 0 minus 1. Okay? Well, of course, 6/5 times 0 goes away. I'm left with this inequality. 0 is greater than or equal to -1. Is that true or false? Is 0 greater than -1? Yeah, it is. It is greater than. Okay? So since it's greater than, that means that's a solution. I'm sorry, since it's true, that means it's a solution. Any point on this side is a solution. So this is the side we want to shade. We can shade either side, but the side we want is this one. That means any point over here in the shaded region or any point on the line is a solution to that inequality. Any questions on that? So let's go with that answer. Graph your line, make sure it's solid, make sure you shade this region. Okay? All right. So let's submit that answer and make sure you got that. Has everyone got it? Let me know when I can move on. Ready to move on, guys? Let's try another one. Okay. All right. So let's try this one now. So y is greater than or equal to -1/2 x plus 8. Okay. So let's check. So first of all, let's graph the line. Just graph the line. Okay. So we're going to start at 8. And then the slope is -1/2, so down 1 across 2. We've done that literally, it seems like a million times now. And now, what kind of line do we want? Solid or dashed? We want a solid line. Okay? If it has the equal to part, it's solid. And now let's test a point. If it's available, meaning if the line isn't going through it, always try 0, 0 because zeros are magical. Okay, so let's go ahead and replace 0 for the equation here. 0 greater than or equal to 1/2 times 0 plus 8. And this is why zeros are magical. I end up with a statement 0 is greater than or equal to 8. True or false? False. So that means any point on this region of the line, below the line, is also false. So we don't want to shade this portion. That's not where the solutions are. The solutions are on the other side of the line. Picture the line as like the border. Okay, so let's make sure we got our shading. We don't want that one. Click it again. We want that one. Any questions? Okay, so make sure you have that and submit the answer. Graph the line, make sure it's a solid line, and you want the shading in this region. And so you can see there's an infinite number of answers, right? Any point on here, either on the line or in that shaded region that goes on expanding forever, is a solution. All right, let's try another one. Okay, so we're at number 3. Let's try this one. And I'm going to continue to push. Here we go. So let's just graph the line to begin with. We're going to start at -6. That's our y-intercept. And then it's 1/3 up 1 across 3. And what kind of line do we want? Dotted or solid? Okay, let's make sure that we got that. let's pick 0, 0. Recognize where 0, 0 is. Let's test that point, okay? So we got 0 less than 1/3 times 0 minus 6. 0 is less than -6. Is 0 less than -6? Nope, it's actually greater than it. So that means anything here is false. This is false. We picked 0, 0, it did not work. That means anything on this side of the line is not going to work. So we want anything on the other side of that line. So we want the side that's not 0, 0, that side. Any questions? Okay. So make sure you have that. Submit your answer. We got a couple more to do. Okay. So I'd like you to try this one. Knowing that you have 2 opportunities, try this one on your own. Try it on your own. We've done a few. Okay. There, I'll give you that much of it. That's at least the line. Now, deciding what type of line and where to shade shall be up to you. And probably because many of you are really good with your mental math, you could probably even do that 0, 0 math in your head, right? If you can, great. If not, So let's just take it step by step. Can someone tell me, or just call out, dotted or solid? Yeah. There's no equal to part, so I've got to change the line. Do I want to shade where 0, 0 is or where it isn't? What do you think? Where it is. So we would have 0 less than 1/2 times 0. We would end up with 0 is less than 1. Is that true or false? Is it true that 0 is less than 1? Yes, it is. So we don't want that side. 0, 0 is not there. We want that side. Boom. Okay, this is the last one, I believe. So let's just kind of do this one together. Yeah, this is example 5. This is it. So graph your line. -3, down 1, across 2. We want a dashed line. We would end up with 0 is less than -1, -3 rather. Because this part goes away. We end up with 0 is less than -3. Is that true or false? Is 0 less than -3? No, it's actually bigger than -3, right? So that means that point at 0, 0 can't be part of the solution. Anything on the other side is. So we don't want this stuff here. We want stuff on the other side of that line. That lower triangle part. This part. So let's go with that. And that's it. So your assignment is to do 15 of these And we'll move on to systems tomorrow. Okay? All right, so the assignment is graphing linear inequalities.